Show you the more technical stuff, which I'm sure a lot of people are interested in seeing. This is the pickup for water. So because I'm going to be living in this van in Switzerland in the winter, you know, it drops down to -15 at the minimum. You know, it's often below freezing. It would be much easier to do what other people do and drill a hole through the floor and have like a P-trap, like an air trap. You know, it stops any smells coming up, and have a grey water tank underneath the van, say like 20 litres, 30 litres. Use that for the shower water for a few days, and then, you know, dump it out, refresh the water, clean it out a little bit. That would be a much easier way to do this, but not wanting any external water is a key part of the design for this van. I want all the water to be within the insulated thermal envelope of the van, basically. So the way that I'm doing it is I'm actually sucking water out using the pump. So even though I have a very powerful pump, they never suck water as well as they can push water. That's just a design with, that's just, you know, something you have to work around with a diaphragm pump. They will self-prime, so they will suck water out. They will do it, but they just don't do it super powerfully. So you need to keep the resistance between this point and the pump as low as possible. So it comes out of here, goes through this dodgy set of elbows. You can see my little heater here, and then it goes into the back. So I'll just get a refocus, and like I say, it goes through here, it goes under the bed, and into this absolute mess. So I'm not going to try and explain everything here in situ because it's impossible. It's impossible to explain it like this because it all goes in random directions. I'll try and explain it on paper shortly, and it's much easier to understand. But I'll just quickly go through the route of the water. It comes in down here through that hole, goes into the pump filter. This is the filter that protects the pump, and actually does a lot of the hard work. It gets rid of most of the hair and bits of dirt and stuff like that. So I will often clean that little mini filter after every day, or every couple of days if I can be bothered. Just because, like I said before, you want to keep the resistance between the pump, the big fat pump, and the where it's sucking water from, keep that resistance to a minimum. So the way to do that is to keep cleaning that little stainless steel filter. After the pump is from C-Flow. It's a 24 volt pump, and I'll flip the specs over for you so you can read them. It's very powerful. It's an amazing piece of kit, actually. Quite a little bit expensive, but actually after using it, I'm so happy with it. It's amazing. So next up we have the filter, 5 micron filter. So 5 microns for reference. Say somebody who had very particularly fine hair, I think it's about 100 microns or something like that. I know that fine sand is about 60 or 70 microns, very fine sand, so it's definitely not getting through a 5 micron filter. This gets rid of most of the dirt, basically. So in my original design, it was actually quite different to this. I had the pump wasn't upside down like this. I had 2 of these filters, and they were on the other side of the pump. I'm going to make another video explaining, for people that want to do these designs, the mistakes I made and how I had to change it on the road to make everything work properly, but that's a topic for another video. After the filter, so we're down to 5 micron clean water now. We've got the UV filter. Now this is a UVC filter, a genuine UVC. It has a quartz bulb in the center and a quartz tube, because that doesn't block the UVC. The water flows into it around the UV lamp in the center, and basically what that does is it kills viruses and it kills bacteria. You need to get one that's sized for the flow rate of your pump, because the way that these are designed in the factory or by the engineers or whatever is for a certain flow rate, so it knows it has enough time for the power of UV coming through at a certain speed to kill everything that's in the water. That would be much more necessary if I was using a water tank underneath the van and recycling the water for longer, because you need to keep, obviously you don't want anything growing in there, and that would kill anything in it. For example, another use of UVC sterilizers like this is in ponds, because it kills the algae in the water, just as an example, so you can see how effective they are. I've just got a little cut off here, and then here we tee off into cold and hot water for the shower. The hot water goes to the heat exchanger, which is over here. From the heat exchanger, I've got my hot water to the shower, and quote, cold water comes just from here. So that is the full loop. I know it's very complicated, and I'm going to try and explain it on paper a little bit more clearly. Yeah, so let's move on to that, and I'll try and explain it as best as I can. Okay, we are ready with pen and paper. I'm not very good at drawing, so this is going to be interesting at the best. So let's start off with the shower tray. This is the shower tray. As I showed you, this is the little pickup pipe that's pulling water out of the base of the shower tray. It goes through the next point, which is the little, oh, fantastic quality drawing. This is the little pre-filter for the pump. Here's the pump. Wow, amazing. There's the pump. So after the pump, then we're going through the big filter. Here's the big filter. That's the 5 micron filter. After that, through the UV. The UV is like a tube like this. The water goes in, goes up, and out the top. And then we'll go back across. Okay, so after the UV, at this point is where the water splits. I'm going to draw the shower wall on. There's the back of the shower. Here's the little shower head with water coming out. And here we're going to put the hose for the shower. And here's the mixer on the wall. So at this point, we can take cleaned. It's cleaned from physical things, it's cleaned from bacterial, viral things. This is now the cold water. But like I said before, it's not super cold, it's just the temperature of the water that's fallen on the ground. So a lot of the time this water is very close to the temperature that you want for a shower, which is really nice. You don't need a lot of heat input after this point. So that goes back to the shower. At this point, you have a non-heated cleaning, recycling shower. This would completely function like this. If you poured hot water into the shower at the beginning, it would actually stay hot for a little bit of time. And I think for a lot of people, this would be very adequate. And yeah, I can't see why this would be a problem. Especially if you're using it like me and replacing the water every time. In the future, I would like to have 2 filters. I'd like to start with a 50 micron and then a 5 micron, just so that they can flow a little bit better and last a bit longer. But I don't know, honestly, it's working pretty good. I changed the filter. So far it's been about once a month, maybe a bit less, because I haven't really been cleaning them. I've just been changing them because they're actually really cheap. You buy a big 10-inch cartridge for a few pounds basically. So yeah, there you go. There's a cold water recirculating shower. The way you get hot water, so we have to make a tea off our cleaned water. Okay, this is the tea. I'm going to draw it over here to give myself more space. So this is, like I say, the temperature of the water on the floor of the shower. This now needs to get heated. The way to heat this is through a heat exchanger. So I'm going to draw the heat exchanger like this. So the heat exchanger has lots and lots of plates. It has a very large surface area inside it. There's loads of plates and the water is going back and through. And on the other side of the plates, you have hot water, which is a completely separate water system. That hot water is going to my big 120 litre hot water tank. There's a little recirculating pump, and that just pushes hot water around and round and round and round and round continuously. And while the water in this tank is hot, it will make the water in the heat exchanger hot, and it will pass that heat onto our water ready for the shower. That goes down to the mixer. The mixer decides how much hot it wants and how much cold it wants to get the temperature that you like, and that's it. Now you have a hot water recirculating shower system. The hot water tank, like I say, the water in here, so this is water 2, water 1 is all of this. So this is completely separate water. You're not getting dirty shower water going into your hot water tank. So the next question, I guess, is how do you get this water in this tank, all 120 litres of it, which is quite a lot, how do you make that hot? The way that I do that is with a diesel water heater. So inside this tank, there's a large coil. It kind of comes almost halfway up the tank, okay, like that. So in this coil, I'm going to draw some more lines, make it more complicated. Draw it down here. This coil is connected to my diesel water heater. So the diesel heater is like a bit of aluminium block, basically. It's got its own pump built into it. So you basically give it one line of cold water, it gives you an output of hot water, and it will just continue to do that until it reaches its maximum temperature, which I think on my diesel heater is about 60 degrees or 65 degrees. So basically for this heater I just have a little diesel tank connected to it. I have electricity, 12 volts connected to it. Quite high amperage, it's about 30 amps it needs, just because when you start it, it has a little heater inside to preheat, like in a diesel engine, it has a glow plug. So yeah, I just press the button, there's a switch, just press the switch, boom, turns the diesel heater on, its own pump starts running, and it starts circulating hot water around and around and around, just continuously, until it reaches its temperature. So again, this is another completely separate water system. This is water system 3. So in this line there's a little expansion tank at the highest point. I've not left myself enough space, but there's an expansion tank like you have in a car. This is basically a car cooling system, and I use the car's radiator tank, expansion tank, to add the liquid to. You have the expansion tank at the highest point. It's because when you're heating up this water, it'll expand and contract, so you need somewhere for that to go and somewhere for it to expand into. So yeah, like I say, this is the third separate piece of water system in this entire system. So I know I haven't explained it super clearly. It's probably about the best I can do. I hope that having it on paper makes it a little bit more simple. So the reason I've chosen to do it like this is everything in this system is inside the van. There's nothing external. There's nothing that can freeze. I mean, it will freeze if you let the van get cold enough. But another reason is because this van is my home, basically. If I'm going to live in it in the winter, in the mountains, where it's -10 or -5 while I'm at work, I can't allow the van to get down to ambient temperatures, because I'm going to start getting mold, I'm going to get condensation. I mean, nobody has a home that they allow to get down to 1 degree when they're at work. It's not something that household objects are designed for. You know, all your fabrics are going to get wet and moldy and horrible. So from this, the idea is in the morning, or maybe on a night, I'm not too sure on how much heating the van's going to need, you can heat the water tank up. So yeah, on a night time or a morning, you can heat this water tank up to its maximum, 60 degrees or whatever. And I have a little heater, so the heater takes off hot water the same place that it does for the shower. And basically all it is like a car radiator. It just has some fins and coils inside it, and its own fan. How do we draw a fan? Let's say like that. And then, you know, it extracts some of the heat, puts it back, and boop, puts it back in the tank. So this has its own little pump on this little pump. This circulates. Well, I've kind of drawn that in the wrong place, but this circulates hot water through this and the heat exchanger. And by having this, I have this connected to a thermostat which turns on this pump and this fan. I can set the thermostat when I leave the van to 10 degrees, 15 degrees C, and it'll just click on automatically and make sure the van doesn't freeze during the day. And this van is very highly insulated and has no windows in the back, and I will be sealing the front of the van from the back quite, not completely, but very well, because most of the heat's going to be lost out of the windscreen and the 2 driving windows. I calculated the heat load at -10 to keep it about 15 degrees in here is about 750 watts continuous. 120 litres of water, going from, I think it was 65 degrees down to 15 degrees. I think I have about 10 kilowatt hours or something like that. I'll have to check up on the maths. I'll put it up on the screen for you, for those that are super interested in numbers. So I have enough energy in this tank to heat the van for a whole 12 hours or 24 hours. So that's my theory. I mean, I'm currently in Portugal and it's about 30 degrees, so it's not being thoroughly tested yet. It really needs to be the cold weather to give it a real test. But that's my idea, and I hope you were able to kind of understand this mess of a diagram. I'm going to make another video talking about my original design and why that failed. So if you're trying to design your own recirculating shower system, then yeah, you want to check that one out. Or I guess it'll be the next thing that I make. And I'm also going to make a video comparing a few of these recirculating systems on YouTube. I know that Snow and Kurt have a cool one. There's some like VanLife YouTubers. Kurt seems to be pretty clued up on this kind of thing. It's really cool videos to see. And there's the original, the Hour Shower, a boondocking guy in America that I think might have started off this trend of recirculating showers. And if I find any other interesting ones, I'm going to compare those two to mine and talk about the pros and cons and things like that. So yeah, I really appreciate you sticking with me on this longer video. I hope it could have been of help, and if you have questions, please let me know, because I'm sure there's something that I've forgotten. Alright, so thank you very much for watching as always, and yeah, I've got a few more videos to make about the shower, things that I did wrong in the first design, how the toilet works. I need to do a tour of the van in total. But yeah, thanks for watching, and I'll see you in the next video. Bye for now.